Bateman's reverse prime sieve of Eratosthenes. Computer friendly. My motto: plain honesty, simple truth, easy understanding, the joy of finding things out for yourself. The simpleton's mathematical coat of arms. In Euclid we trust. We start with a header row of all the odd numbers. The first column will contain all the primes as and when we find them. We fill all the rows with the first 9 odd composites of its initial prime by adding 2 times the prime to each preceding cell. 9 is only my choice for this presentation, but in reality we only need 2 composite cells per row, resulting in the columns 3, 5. We start with primes 3, 5 and their first 9 odd composites. Note that 2 cells contain 15, since 3 times 5 equals 5 times 3. At the start we have 3, 5, a gap, then 9, so 7 is the first prime we have found. We insert the row for 7 with its composites. We now seek the primes between 9 and 15, which are 11 and 13. We insert the rows for 11 and 13 with their composites. Since 9 was smaller than the new primes, we replace it with 15 from the adjacent cell and the row updated. We now seek the primes between 15 and 21, which are 17 and 19. We insert the rows for 17 and 19 with their composites. Since 15 was smaller than the new primes, we replace it with 21 and 25 from the adjacent cells and the rows updated. We now seek the prime between 21 and 25, which is 23. We insert the row for 23 with its composites. Since 21 was smaller than the new primes, we replaced it with 27 and 35 from the adjacent cells and the rows updated. We observe that 25 and 27 are consecutive, so we seek the primes between 27 and 33, which are 29 and 31. We insert the rows for 29 and 31 with their composites. Since 27 and 25 were smaller than the new primes, we replace them with 33 and 35 from the adjacent cells and the rows updated. We observe that 33 and 35 are consecutive, so we seek the prime between 35 and 39, which is 37. We insert the row for 37 with its composites. Since 33 and 35 were smaller than the new primes, we replace them with 39, 45, 49 and 55 from the adjacent cells and the rows updated. We now seek the primes left between 39 and 45, which are 41 and 43. We insert the rows for 41 and 43 with their composites. Since 39 was smaller than the new primes, we replaced it with 45 and 65 from the adjacent cell and the rows updated. We now seek the prime between 45 and 49, which is 47. We insert the row for 47 with its composites. Since 45 was smaller than the new primes, we replaced it with 51 and 55 from the adjacent cells and the rows updated. Since 49 and 51 adjacent, we seek the prime between 51 and 55, which is 53. We insert the row from 53 with its composites. Since 51 and 49 are smaller than the new primes, we replace them with 57, 63 and 85 from the adjacent cells and the rows updated. Since 55 and 57 adjacent, we seek the primes between 57 and 63, which are 59 and 61. And so on and so forth ad infinitum.